can hear my frustrated
Okay.
sounds on this.
This is lesson 8.4, number 11 from page 427. We may have done it earlier using traditional method. Now we're going to do it with p-value method. So it's still hypothesis testing. It's just two different methods that can be done to solve hypothesis testing. Number 11 says this: the average undergraduate cost for tuition fees and room and board for two-year institutions, we're talking something like Kirkwood or something like that, or maybe NICC, last year was $13,252. The following year, a random sample of 20 two-year institutions had a mean of $15,560 and a standard deviation of $3,500. Is there sufficient evidence at the alpha equal 0.01 level to conclude that the mean has increased? So they're asking, is the mean now greater than $13,252? So that's going to be our claim. The null would be that the mean is less than or equal to 13,252. In other words, it has not increased. The sample size was 20, which means degrees of freedom would be 19. The sample mean is 15,560. Sample standard deviation is 3,500. Alpha equals 0.01. So what that means is there's only a 1% chance of type 1 error. There's only a 1% chance that if the null is true, that we will reject the mean. Or, excuse me. There's only 1% chance that if the null is true, that we will reject it. That would be an error, right? If this is true and we reject it, that's an error. There's only 1% chance it's going to happen. Okay? So we're pretty sure about our results here. This was step A. Step B is compute the test values. Test value. Since we don't know the standard deviation of the population, and n is less than or equal to 30, we're going to use our t-distribution. You're going to take the sample mean, which is 15,560, minus the hypothesized mean of 13,252, divided by S, which is 3,500, divided by the square root of n and the square root of 20. Anyone tell me what that comes out to?
2.94.
2.95?
Yeah.
Here's our t-score. Two-tail, right tail, or left tail, which is this?
Right.
Yep. Look at the alternative, it points right. We're talking about a right tail test. So for part C here. Over here, probably actually out further than that because we know 99.7% of the data falls within 3 standard errors of the mean. So we're at 2.95, so that's our test value right there. T equals 2.95. So the area to the right of that is what we call the p-value. So we need to find that area. If that area is less than 0.01, we'll reject the null. If it's not less than 0.01, then we won't reject it. Okay? So you go to your t-chart, okay, and you go down to degrees of freedom, 20 minus 1 or 19. And you go across looking for 2.95. Okay? Probably won't be there though. As I look across at 19, I see 0.688, 1.328, 1.729, 2.093, 2.539, 2.861, and I just keep getting bigger and bigger. 2.539, and I see 2.861. So 2.95 is somewhere out here, isn't it? To the right. Okay? Somewhere out to the right of all these numbers that were listed here. So it's bigger than all those numbers. If you look up top, it's a one-tailed test. Look up here at one tail. So dealing with one-tailed test. You notice like this is 0.005. This is 0.01. Before that is 0.025. So these numbers are getting smaller, aren't they? This is where I'm trying to get my p-value from up here. For example, if my test value is 2.539, then my p-value would be 0.01. If my p-value was 2.8, or my test value is 2.861, my p-value would be 0.005. Since my test value is bigger than these numbers, my p-value will be what compared to this number? Smaller. These are getting smaller, right? These numbers are getting bigger, these are getting smaller. So because my test value is bigger than 2.861, my p-value is less than 0.005. So that area we know is less than 0.005. If it was two-tailed, we'd have to look at the two-tailed column instead of the one-tailed column. Okay? So, if it's less than 5 thousandths, wouldn't it be less than, let's rewrite that as 10 thousandths? Right? This is 10 out of 1,000. This is 5 out of 1,000. So, if the p-value is less than 0.005, then it's definitely less than 0.010. Okay? So we can say that for part D, p-value is less than alpha, so what? Reject the null. Step D, you're always going to say reject the null or do not reject the null, every time. Those are your only options. Step E, if we're rejecting the null, that means we think it's false. That means the null, we're thinking that is true. So we're going to say there is enough evidence to what? Support the claim. Yep. There is enough evidence to support the claim that let's word it the way they worded it. The problem here. The question was, is there enough evidence to conclude that the mean cost has increased? We're saying, yeah, there is enough evidence to support the claim that the mean cost has increased. Or you could say that the mean average cost is more than $13,252. It's a good example of a p-value problem using the t-distribution. Any questions about that one?